Hi, everybody. Welcome to today's webinar. We'll get started in about a minute or so. We'll just let everybody join here. Awesome. I think we can probably get started now. So thanks everybody for joining. In today's webinar, we will be diving into how Validere can help unlock the full potential of your measurement data to support various outcomes. By the end of this webinar, you will learn how Validere can be leveraged to 1, capture and structure measurement data from various sources, 2, integrate measurement data into existing workflows to streamline operations and improve decision-making across your organization, and 3, gather actionable insights from the consolidation of all of this data by identifying trends and quantifying uncertainties. To tie all of these concepts together, we will also be walking through a case study on how we can leverage measurement data and operationalize your processes to achieve OGMP 2.0 Level 5 certification. Awesome. So here is our agenda for today. We'll start with some quick introductions. My name is Priyanka. I'm an engagement manager here at Validere, and I help oversee the implementation of the Validere platform for a variety of use cases within emissions management, EHS, and operations. Cyrus on the call here today will also be presenting. He is the lead solutions architect at Validere and specializes in developing solutions for some of the more complex and exciting industry challenges. So I'll kick things off with a brief presentation to lay the groundwork. I'll start with talking through specific measurement data use cases we currently support our customers with. I'll then provide a high-level overview of how we can help develop a measurement sampling plan, perform emissions quantification at the source and site levels, and also perform reconciliation between both of these levels. I'll then hand it over to Cyrus, who will do a comprehensive live demo in the product and talk through all of these concepts in a lot more detail. Before we get started here, we have a quick poll for you all. The question in the poll today is, what is the most critical challenge with administering your measurement programs? And the options that you can select in the poll are 1, correctly managing and quantifying uncertainty, 2, data integration and compatibility issues, and 3, field deployment and operational challenges. So super excited to see everyone's responses to this poll. We'll be keeping tabs and can revisit this towards the end of the webinar. Awesome. So getting started here, at a high level, Validere is a data source agnostic and vendor agnostic platform and can bring in any sort of measurement emissions data in a standardized way, such as continuous emissions monitoring sensors, satellite data, aerial flyover data, SCADA data, and also field inspection data. We're also able to quantify emissions using a bottom-up approach by leveraging asset inventories, operational data like equipment hours and load factors, emissions factors, and also engineered estimates. Ultimately, Validere is able to consolidate and structure both measurement data and estimated emissions data in order to generate reports, facilitate specific emissions analyses, and also trigger workflows for taking action on the data that is received. And so some specific examples of this can include comparing and reconciling top-down and bottom-up emissions as required for OGMP 2.0 Level 5 certification, developing a measurement-informed inventory, live emissions event alerting, as well as emissions threshold exceedance analyses. Let's now dive deeper into specific measurement data use cases that we have helped our customers with. So we're able to consolidate any type of measurement data in Validere to develop measurement agnostic dashboard views. So instead of field teams having to rely on various vendor-specific dashboards, Validere provides a holistic and single source of truth to understand emissions profiles across all sources and identify the highest emitters. With respect to field inspection data, we have built out workflows for leak detection and repair, and also for field data collection. So examples include pneumatic leak rate tests using high flow samplers and engine stack testing to derive methane emissions factors. As another example, using SCADA and field measurement data, we have helped customers develop corrective actions related to specific events like temperature drops and flares to identify unlit flares and pressure drops to validate blowdowns. And in addition to all of these tactical applications of how we leverage measurement data, we also allow for the utilization of this measurement data for deriving emissions. So we'll now focus on how Validere is able to leverage and standardize measurement data to undergo both level 4, emission source level quantification, as well as level 5, site level quantification with respect to OGMP, including the reconciliation between both of these levels. At a high level, Validere is able to help with all parts of the OGMP process, including developing measurement sampling plans. We're first able to do this by creating a robust asset inventory and performing bottom-up emission factor-based quantification using an established methodology like Subpart W. We can then leverage this emissions data to very easily produce analyses on how to stratify assets based on similar emissions profiles and identify the emissions materiality within those stratums. This data can then be used to inform a sampling plan to only sample a subset of sources and sites. And this sampling plan can be administered in Validere, which Cyrus will showcase in more detail in the demo. Once the sampling plan has been developed, the next step is to execute the sampling plan at both the level 4 emission source level and at the level 5 site level. So examples of emission source level sampling could include collecting pneumatic vent rates, executing stack testing, and doing engine testing. And as we discussed earlier, examples of site level sampling could include doing aerial flyovers and leveraging continuous emissions monitoring sensors. By utilizing the measurements collected from executing the sampling plan, we can calculate emissions distributions at both the emission source and at the site levels. And this approach allows us to estimate the uncertainties and predict how methane is likely to be emitted from a source or from a site over a given time period. These emissions distributions and uncertainties can then be extrapolated to the entire emission source population and site population to derive a holistic emissions quantification picture. Finally, the estimated emissions at the source level can be compared with the estimated emissions at the site level to understand how closely they align with one another. And this really correlates to the reconciliation that's required for OGMP 2.0 level 5 certification. Validere can help you understand whether your level 4 and level 5 emissions reconcile, and if they don't, we can help you further investigate where the uncertainties may be stemming from via actionable dashboards and via reports as well. Cyrus will discuss the OGMP case study and this reconciliation piece in a lot more detail in the demo, so I'll hand it over to him now. Thanks all.
All right, awesome. Thanks for the introduction and kind of giving us a little bit of background there, Priyanka. So shifting gears here, I'm actually going to be taking us into the product, and I'm going to be showing you guys essentially how we are going to actually implement some of the practices and some of the ideas that Priyanka has just introduced within the Validere platform. I'm also going to be showing you guys and talking a little bit about how some of the issues that we typically see companies running into when it comes to implementing a measurement program can be addressed through the platform. And we'll get into that in a little bit more detail. So just a quick reminder before I jump into this, we're going to leave some time at the end of the session for Q&A. So as I'm going through this, if you have questions about anything that I'm showing or you want me to go into more detail on any of these topics, just leave a question in the Q&A session and we're going to try and get to all of these at the end. So I'm going to share my screen. Veronica, maybe just give me a thumbs up when you guys can see this on your end. Perfect. So jumping into the product here, the account that I'm going to be walking through today has been configured with an asset base that largely resembles what you might see at sort of a typical upstream producer. And that's in terms of the types of sites and facilities and the actual kinds of emission sources and equipment that exist at those facilities. Now, something to keep in mind as I'm going through this, although this specific implementation has more of an upstream focus, a lot of the concepts and a lot of the practices that you're going to see here would apply at any level of the value chain. So specifically the way that we're doing things like managing asset inventories, implementing measurement data, running calculations, those same principles are going to apply regardless. So looking specifically at the information that's summarized on this homepage here, you can see that we've populated this account with several hundred sites or facilities. And then we've actually also run bottom-up emissions calculations on all of those locations. So here you can see that actual emissions total. Now, in this case, we've actually used calculations from the Subpart W methodology. So basically what's happening is we're using calculations that exist within the Validere platform. We're applying those to specific sources, and then we're evaluating the emissions results that we're obtaining from those calculations. So as a user, if I want to start drilling into this data in more detail, a great place to start would be looking at my asset inventory, and I can access that by clicking into organization on the left here. So when I do this, I have the option to select from my facilities, my equipment, or my devices. In my case, I'm actually going to look at my facilities. So clicking into the facilities tab, I get this quick view of all of the site level assets that I'm tracking emissions across for my entire account, along with some high level information about each of these locations. Now, for those of you who are familiar with the product, you'll know that the attributes and the fields that we're actually tracking here are entirely configurable. So what that means is if there's additional fields or if there were additional attributes that you wanted to track on these assets, those can be added here. And then they can be used to do things like categorize your assets or contextualize the data that you're actually storing on those assets. So as an example, we've implemented an attribute in this account called site type. And basically this site type attribute is being used to create a broader classification that our facilities can then be bucketed into. So this is a useful tool for creating basically different groupings of assets, and it kind of makes it a little bit more manageable for us to look at our emissions results and perform analyses on top of that. So from here, if I want to drill into the results a little bit more, I can click into one of these specific facilities, and this pulls up all of that high level information, as well as a breakdown of all of the equipment or the emission sources that exist at that specific site. Now, to tie this back to the actual OGMP implementation process, these are the sources that I actually need to establish my level 3 inventory for and my level 4 inventory for. So the emissions results that we were looking at before are basically the result of calculations that we've applied to these specific sources. So essentially what we've done is we've taken examples of subpart W calculations and we've applied that to these heater treaters, these separators, essentially all of these pieces of equipment. So if I wanted to look at the specific emissions associated with this facility, I can click into this emissions tab. And what I'm going to get a look at is basically the breakdown of all of those subpart W emissions results on a month over month basis. So basically what I'm looking at here is my month over month level 3 inventory. Now, if I want to drill even more into this, I can click into a specific month. And when I do this, I get that breakdown, but this time I can actually see how much of those emissions are being attributed to individual sources. So what I'm looking at here is basically an individual month of my level 3 emissions inventory. So to kind of quickly summarize what we just looked at here, we've basically talked about how assets and asset inventories are organized within the product, and then how you can actually use the Validere calculation library to run calculations on top of those sources. So essentially what we've done is we've created a generic level 3 bottom-up emissions inventory. Now, for the purposes of OGMP, building up that bottom-up emissions inventory is really sort of the first piece of the puzzle. But where we see companies typically struggling is actually when it comes to ingesting and managing measurement data. Now, within the Validere platform, we typically handle measurement data in one of two ways. And the first of those is through what we call measurement enriched forms. You can think of a measurement enriched form as basically a form that's been configured to capture the results of like a test or an inspection, really any sort of episodic measurement event that benefits from additional metadata or additional context. So typically we use forms to capture things like the results of aerial flyovers or stack tests as an example. So coming over here to the form section of the product, I can see all of the form categories that we've created. In this case, the one that I'm the most interested in is this OGMP measurement category. So when I click into here, I get a view of all of the templates that we've created for the purposes of capturing the OGMP measurement data that I'm interested in for this implementation. So you can see we've got one for aerial flyovers, we've got one for heater stack test results, so on and so forth. Really, these can be configured to capture whatever type of measurement data you're interested in. And it makes it very flexible to bring all kinds of data into the platform for sort of further analysis. Now, if I actually want to see the specific data that's been pulled in, I can click into one of these templates. And in this case, I actually get a view of the actual measurement values that have been brought in, when those measurements were actually captured, and then the very specific emission sources and sites that those measurements are tied to. Now, this level of sort of measurement data granularity and this kind of measurement data organization becomes really important down the road when we start to try and build out our level 4 measurement informed inventory. And we're gonna be talking about that more later on. Now, the other sort of primary way that we'll typically bring data into the platform is through what we call devices. And you can think of a device as like a sensor or a meter or a gauge. Typically, they're used to capture time series data. So applications are things like flow meters, or in a lot of cases, we'll actually use them to capture emissions monitor data. So in this account, we've actually created a bunch of examples of methane emission sensors. And basically, each of these sensors is representative of an actual device that you might have out in the field, capturing data on an ongoing basis. So if I click into one of these actual sensors, first I can get a view of sort of the information about it, and then I can actually see what types of measurement data this device is actually pulling in. So in this case, I can see that we're capturing methane concentration data, and then also a methane emissions rate. And if I want to see what that data actually looks like, I can go to the measurements tab, and here I get a view of the actual data that's being housed on this device. So here I can see all of the methane concentration data that we captured from this device for the month of January. Now, with device data, same as with form data, the actual measurements that we're bringing in can be associated with specific assets, so specific equipment or specific facilities. And that dynamic makes it a lot easier for us to begin to evaluate and analyze the data as it lands in the product. And ultimately, that makes it more valuable for supporting these downstream use cases like OGMP. Now, outside of OGMP, one of the use cases that we often see people bringing real-time emissions data into the product for is what we sort of call emissions monitoring. So an example of that is basically you would have a collection of emission sensors at a specific site, and you want to be able to evaluate all of that data in one consolidated view to get an appreciation for what's happening at that site and potentially to help identify any sort of emissions events. So in this case, we have a dashboard here called Continuous Emissions Monitoring. I'll open that up. I actually have a version of it already loaded here, so I'm just going to move over to this one. And basically what I'm seeing here is a consolidated view of methane emissions data that's been pulled in by my devices and aggregated up at a site level. So in this case, I'm actually looking at all of the methane sensors at this specific site here. So it's VR, TXBPP, and I can see how that methane concentration data is trending, in this case, over the month of January. So you can see that a lot of my sensors picked up a spike sometime on January 18th, or then in this chart on the right, you can actually see the calculated methane emissions rate. A lot of these sensors will derive a methane emissions rate based on the concentration data that they're reading. So we're also pulling that in, and you can see that, again, that methane emissions rate seems to tick up at the same time. Similarly, if you want to kind of get a little bit more granular in that view, you can come down here and you can actually pick out a specific device from that set. So if I had 8 devices at my site and I only wanted to look at one, I could come down here to analyze that. So basically, this is a view of that same data, but this time it's filtered down to only just look at one instance. I can see my concentration and my emissions rate data over that entire month. Or if I want to get a little bit more specific, I can look at that data for just an individual day. So this is a very standard example of what an organization might do with measurement data once it's been properly ingested into the product. But really, once the measurement data is landed, the opportunities kind of become whatever you want them to be. And the complexity of these use cases can really scale depending on what you're trying to accomplish. So that's just sort of a brief overview of some of the things you can do with measurement data. To kind of take it back to OGMP more specifically now, we've kind of introduced some of the key pieces that are really going to feed into this. And so I'm going to show you guys how we can take advantage of the fact that a lot of this data is all contained within this single system and how it can be pulled together to support the rest of this OGMP implementation process. So to do this, I'm going to bring us into this dashboard here called emissions quantification. Essentially, this emissions quantification dashboard is going to be pulling in a lot of the key data, some of which we've already looked at, to help me make decisions about how I can advance my OGMP process. So basically, this is going to help me navigate the remainder of that. So I'll click into this one. I actually think I've already got it loaded over here. But basically, what I'm looking at here on this first tab, which we're calling emissions overview, is a summary of all of that emission calculations for our level 3 results. So basically the emissions results that we were looking at earlier, those subpart W style calculations, those are being pulled into this specific dashboard so I can get a view of what my emissions breakdown is at both a site type and a source type level. So essentially that data is being aggregated up so that I can see what my emissions profiles are across my various site categories and my source categories. Now, one thing I want to quickly reference back to is that the attributes that are being used to differentiate my emissions profile across my various sites in this specific chart are actually the same attributes that I was showing in the facility screen earlier. So because these attributes can all be managed from within the platform, the implication of that is that as a user, as your assets evolve and as your OGMP implementation becomes more sophisticated, you can adjust these categories and you can kind of create more specific and more accurate views of your assets. So this is kind of an important concept in what we call asset stratification. Scrolling further down on this dashboard, I get a more detailed breakdown of my emissions. So in this table on the bottom left, what I'm actually seeing is basically a breakdown of my emission sources and their corresponding methane emissions based on the site that that source belongs to. So for example, here I can see that my flares at my first site category have emitted just over 30 tons of methane. And for comparison, I can see that my flares at a different of my site types have emitted over 250 tons of methane. So basically, this is helping me sort of differentiate the emissions profile for my various sources across my various site types. And then in addition to that, I can also see how many of those sources actually exist for each of these sites. So for instance, here I can see that I've got 32 flares at my site type A, and I've got 176 at my site type B. So that's sort of one way of viewing this data. In this chart on the right, we have another sort of way of kind of breaking this information down. And essentially, we're looking at the same results here, but this time I actually get a sense for how much my individual emission source is contributing to the overall emissions profile for these various site types. Now, ultimately, why we're interested in this data and why we're surfacing this data in this tab is because this is the type of information that's going to inform the next sort of key step in our overall OGMP implementation. And that's the materiality analysis. So basically, how do I figure out which of my sources are material and which are immaterial? So to look at that data, I can move into this next tab called materiality analysis. And the objective of this analysis is to provide a framework that can help guide decision-making around how I implement my measurement program. So basically, what sources and sites should I be measuring, and how can I administer those measurements in a way that reduces the uncertainty associated with the values that I actually extract from the data? So looking at this tab, what we get at the top here, we have a breakdown of the actual number of facilities in each of those buckets that we created. So I've got 160 in type A, 176 in type B, and 164 in type C. And then looking to the left here, what this table is actually basically a summary of a piece of guidance that comes from an OGMP document that some of you might be familiar with. Essentially what this table is summarizing is the sample coverage that an organization should be targeting for their various sources based on the characteristics of those emission sites and those emission sources. And that's a determination that's made based off of a number of factors. So specifically, what we're looking at is the complexity of a site or source. Basically, how complicated is the emissions profile, and is there a reason that you would expect there to be a high degree of variability? What is the overall materiality of the emissions contributed by that site or source? So is it contributing a lot of my emissions or a relatively small amount? And then finally, the population size. So basically, how many of these actual sites or sources do I have? So as an example, if I were considering a complex site versus a simple site, so maybe something like a gas plant versus a well pad, for a simple site that has a high emissions materiality and a large population size, I only need to target a sample coverage of around 10%. Whereas for a complex site with those same other characteristics, I'm looking at more like 40%. Now, the reason for this difference is because ultimately our objective is to reduce uncertainty. And for a facility like a gas plant, where one might reasonably expect there to be a lot of variability in terms of the emissions that are being produced across different instances of that site, you need to measure more to get a clear view of what that emissions distribution actually looks like. So basically, by measuring more, you can reduce the chance that certain outlier data is going to skew your results, and you'll either estimate too high or estimate too low. So this table is really intended to provide sort of a reference that you can use to benchmark your own measurement campaigns against. basically, as you go out and you start to collect data, you can use this to evaluate how much you have collected versus how much you should collect. Now, depending on what your specific organization looks like, what your specific assets look like, it's possible that you might want to adjust the parameters that are going to inform these various sample coverage plans. So for instance, I might want to increase my emissions materiality threshold. I could take it up to 20% versus 10%, or I might want to change my population cutoff classification. I could put this to 200. And basically, as you adjust these parameters, you can see the impact that has on the sample coverage plan that you're being proposed using this guidance. So when I scroll down here, I can actually see how this guidance has been applied against my own specific assets. So in these three tables, what I'm getting is a breakdown of my emissions sources across my sort of major categories. So in the top left here, I can see which of my major emission sources are contributing what fraction of my overall methane emissions. So for instance, looking here, I can see that my pneumatic valves are contributing over 50% of all the methane at my site type A. And that's based on those level 3 calculations that we perform. So basically, we're rolling up the information that we've already previously obtained, and we're using that to inform our approach to the next step of OGMP. Similarly, I can look at my actual absolute counts. So essentially, how many of each of these sources exist at those site types. So I've got 451 oil tanks at my site type B. Now, ultimately, these are the variables, along with the parameters that we were looking at up above, that are going to dictate how much a specific source should be sampled. And to see those results, I can come down to this table here. So, for example, looking here, I can see that for my heater treaters at site type A, these have been determined to have a high emissions materiality classification. They have a large population size. And based on that, it's recommended that I target at least a 15% coverage, or against my emission source count of 160, I should look to develop a sample size of at least 24. So this kind of provides a framework that you can use to plan how your measurements are actually going to be administered and how you can actually go out and determine what things to measure and how much to measure them. As a quick side note, typically sources are modeled as simple, but there's nothing preventing an organization from determining that they want to treat a specific source as complex. Really, all it means is you're just going to tag it differently. And then when it comes time to measure, you're probably going to be suggested to measure a little bit more. Now, this same idea of sample planning that we've just looked at the source level can also be applied at the site level. So scrolling down here, I see a lot of that same information, but this time it's being aggregated up to the site type category. So in this table on the top left, I can see my methane emissions contributions from each of my major site types. In this case, looks like my site type C is contributing the vast majority of my overall methane emissions, whereas site type A is contributing a relatively small amount. And then again, similarly, I can see what those actual population counts are. So 160, 76, 164, and so on. And then again, just as we saw above, basically we're getting those same results, but this time it's informing my top-down measurement approach. So basically, looking at site type C, for instance, I can see that this has a site complexity of complex. It has a high emissions materiality classification, a large population size. And so it's recommended that I sample at least 50%, or I want to collect at least a sample size of around 82. So ultimately, why we do this analysis and what we use this for is to make determinations about where we should measure and how many measurements we can collect. And that kind of feeds into this next tab, which we call sampling comparison. So opening up this next tab, what I'm presented with is basically a view of a lot of the same information I was looking at in that last tab. The main difference here is that we actually have the ability to track the progress of our measurement campaigns against those recommended sample minimums. So for instance, looking at my heater treater type A's, I can see that based on the guidance provided in that last tab, I'm recommended to get at least 24 measurements. And I can see that based on the data that we've actually pulled into the platform, so the measurement data that's actually being extracted from sort of our field operations and pulled into the Validere product, I can see I've actually already exceeded that threshold. So I've sort of met and satisfied that minimum requirement. Similarly, if I come down here, I can look at my wellheads. You can see that recommended minimum is 65, but in this case, I actually still have a few additional measurements that it's recommended I capture. So this is just a good way of sort of tracking your progress and ensuring that as you go out and you actually conduct these measurements, pull this data in, that you're sort of satisfying that sort of minimum level, and it sort of facilitates some of the conversations around ensuring that your uncertainty is reduced to a reasonable level. You can also see in this table that for some of these sources where we haven't yet implemented a measurement program, so basically we're not ready to move to level 4 yet, we just don't have any measurements. Similarly, down here, we have that same concept, but this time it's applied at the site level. So basically my recommended minimum count for site types A, B, and C, and how many of those site level measurements have actually been captured. So to quickly recap where we're at in the overall OGMP process, basically what we've done is we established sort of that basic asset inventory. We've built out a level 3 emissions inventory using that asset base. We've performed asset stratification to get an understanding of sort of how our assets are distributed and what emission sources exist within which sites. And then we've used that information to perform a materiality analysis. And that materiality analysis is in turn informed this sample plan that we've just been looking at. So basically, how much sampling do I need to do and where do I need to do that sampling? So with that in hand, what we've done is we've gone out, we've actually started to collect measurement data. And the next step in the process is to actually use that measurement data to inform our overall level 4 measurement informed inventory. And so that's what we're going to start to look at in this next tab. So bringing up this next tab, what we're presented with is basically a view of all of the measurement data that we've actually ingested into the product up to this point, along with a few key parameters. And these are the key parameters that we're actually going to use for our OGMP purposes. So looking at this top table, I can see what my mean methane emissions rates are, and these are the rates that have been calculated from the measurement data that I've collected on my various sources. Now, in addition to that sort of basic mean emissions rate, you can also see that there's an uncertainty, and I'm going to talk a little bit more about that. One thing that I think is important for sort of any OGMP conversation, but one of the sort of key ideas here is that the way that the assets are organized and the way that the measurement data is organized allows us to create more specific and more accurate emissions factors. So for instance, I don't just have a single emissions rate for my heater treaters. I actually have a different one based on the site type that those heater treaters are at. So that basically means that I can differentiate between the emissions profile I would have for a heater treater at site A versus at site B. And in the spirit of OGMP, that's kind of a process that we're always looking to improve on. So we're always trying to create more accurate emissions factors and more specific emissions factors. Now, talking about the uncertainty, as you can see for each of these factors, we also have an associated uncertainty. And that's a really key piece for any OGMP implementation, basically understanding uncertainty and understanding how to approach uncertainty. Now, typically, deciding how to quantify uncertainty takes some careful consideration. So one of the intentions of this dashboard is to surface a view into the measurement data in such a way that can help facilitate decision-making around how you want to quantify your overall uncertainty. So when I scroll down towards the bottom of this table, what I'm actually presented with is a view of the distributions that are beginning to be created by the measurement data that I'm actually pulling into the platform. So basically, as I capture data in the field and as I begin to ingest that data into the platform, I can get a sense for what the actual distribution of those results look like. So here I can see how my pneumatic valve distribution at my site type B is beginning to take shape. And I can see how those distributions are evolving from site type to site type. Now, getting a sort of a view or a sense for what these distributions look like is a really key step in determining how to quantify uncertainty. Because, for example, if you evaluate these distributions, you identify that in some cases you have a normal distribution, in other cases you have a skewed distribution. You're going to have to employ different strategies to correctly understand what the uncertainty associated with the values that you're actually calculating from that data are. So the intention here is to sort of provide an overview of that data. And then additionally, because all of this data is actually being captured in the platform, if I want to, I can click into this and it'll actually take me to the location within the product where the data that's feeding those distributions is actually being pulled from. So in this case, I can actually look at my pneumatic valve venting measurements. Here I can see all of the measured rates that we've actually captured in the product, and I can see how those are associated with specific pneumatic valves and specific sites. Now, an additional advantage to structuring our measurement data this way is that as organizations become more sophisticated in their OGMP process, basically as they start to introduce additional assets, as they begin to ingest additional measurement data, this historical measurement data can continue to be used to refine those emissions factors and also to contribute to the discovery of new ones. So for instance, let's say in my next year's OGMP implementation, I wanted to introduce a site type D. Then basically what I can do is, because the values that I've already captured are tagged to specific facilities, as I begin to reassign those facilities to that new category, I already have a bunch of data that's going to inform the distribution. So I have a sense for what that mean emissions rate might be, and I have a sense for what that uncertainty looks like. So it makes it relatively easy to sort of refine and improve emissions factors over time, which is very much sort of in the spirit of an OGMP implementation. So ultimately where we're at now is we've determined some source level emissions factors, and the next step would actually be to extrapolate these results across their applicable pools to determine essentially what would become your level 4 emissions inventory. So these are the values that you would look to, and when it actually comes time to prepare your OGMP report, these are the values that you would need to reference. Now, following sort of the build out of that level 4 emissions inventory and the determination of these source level values, the next step is to incorporate that top down element. So basically to bring in all of those site level measurements that we were looking at before and begin to do a very similar exercise, but this time instead of at the source level, at the site level. So that can be facilitated through this next tab, which shows data that's very similar to what we were looking at on that last one. I think it's just loading up again here. The key difference being that the parameters that are being calculated here and the data that's being surfaced here is all at the site level as opposed to at the source level. So again, in this top table, I get a view of sort of my mean methane emissions rates across my major site type categories. And I also get that uncertainty. So basically, like what is my associated uncertainty? Additionally, I can see that same distribution down here. And if I want to, I can click into a specific data source and I can actually evaluate what measurement data we've brought in to inform those distributions and to inform those calculations. Now, an additional piece to this, sort of on the uncertainty front that's important to take into account is that in addition to the statistical uncertainties that I've been talking about, so basically the uncertainty on the values that we're calculating, you need to account for the fact that there's a certain level of measurement uncertainty. So basically all of the measurements that we're pulling into the platform, there's a level of inherent error associated with those. So any uncertainty value that's being calculated here needs to account for sort of the cumulative effect of the uncertainty from my statistical distribution, but also the uncertainty associated with the actual measurement values that I'm surfacing. And so basically what that means is as I begin to calculate results using these values, those uncertainties are going to propagate forward. So when I look at my sort of cumulative OGMP level 4 or my cumulative OGMP level 5, I can evaluate what the uncertainty on those sort of aggregate values are. So at sort of this point, where we're at in the OGMP process is we've established that sort of basic level 3 emissions inventory, which is what we were looking at the beginning. We've created that level 4 measurement informed inventory using the values that were calculated in that last tab and then extrapolated across the rest of the products. And then finally, we've created a site level emissions rates. And these are the ones that are going to be extrapolated across our sort of sites to create our level 5 inventory. So at this point, what remains to be done is basically to perform a comparison of the results that have been obtained using these different approaches, sort of with the intention of identifying in cases where there is a discrepancy between the values that I've calculated using my various approaches, what's driving those discrepancies and what can be done to remove those. And so we can kind of begin this investigation in this next tab, which we call our reconciliation tab. So ultimately, the objective of this is to evaluate why the differences I'm observing in my results exist and how I can go about diminishing those issues. So basically, if there's a problem in my measurement program, how can I identify where that problem is and what can I do to rectify it? So in this chart at the very top, what I'm presented with is basically a breakdown of my emissions totals across my level 3 and my level 4. And essentially, these are summarized across my major emission source categories as well as my major emissions type categories. So right away, you can see that for the emission sources that we've implemented a measurement program for, there's some level of disagreement between our level 3 and our level 4. So for instance, I can see that for my heater treaters, actually at all levels for types A, B, and C, my OGMP level 4 values are exceeding my OGMP level 3 values. And similarly for my pneumatic valves, I can see that my level 3s are exceeding my level 4s. Now, when you're evaluating this information, it's important and useful to have a certain level of business context and operational context so that you can make determinations as to why these discrepancies might exist. And in addition to that, it makes it easier to identify when you see a big discrepancy that can't really be explained, is that cause for an additional investigation? So like basically, is that the result of an issue in my measurement program? Or is that just something that I don't have context on and I can't really explain as a consequence? So from the top here, what we're looking at is our level 3 versus our level 4. But to sort of expand on this a little bit more, I can come down and I'll actually start to look at my level 4 versus my level 5 results. So essentially what's being summarized here is we're aggregating our level 4 inventory results up to a site level or up to a site type category level to make direct comparisons with the emissions results that we've calculated for our level 5 inventory. So in the chart on the left here, for instance, I can compare my type A level 4 results and my type A level 5 results. In this case, you can see that my level 4 for that type A facility are actually exceeding the results for my level 5. But when I look at my type B or my type C facilities, that trend actually reverses. And this is sort of where we get down to this idea of beginning to investigate why those differences exist. So looking at this chart in the middle, we actually see that same information presented again, but this time with the uncertainty associated to those values. Now, in an ideal implementation, if things have been done correctly, what you want to see is some level of agreement between those two values, at least within the bounds of their uncertainty. Now, when we talk about reconciliation, really the intention here is to begin to identify in instances where there is disagreement, what's driving the difference. So basically, like, why is my level 5 different from my level 4? So for instance, if I was looking at this and I saw that there was just a complete disagreement between the values that I brought in for my level 4 calculations versus for my level 5 calculations, what can actually be done to explain the source of that discrepancy, and how can I use the data that I actually have in the product to begin to investigate what can be done about that or where that information is actually being stored. Now, in addition to that, we also have the ability to drill down into these results on a site-specific level. So for instance, over here, what I'm looking at is basically my level 4 OGMP inventory results for my site VER, TX, DIC compared against my level 5. And if I wanted to get more specific, so for instance, if I wanted to look at a different site, I can filter over to one, and that's going to pull up, again, those same results aggregated to the specific level that I'm interested. So in this case, I can see for this facility, there's actually significant disagreement between my level 4 and my level 5 results. And what that might be an indication of is that there's an issue with my measurement program, either at the source level or at the site level. And so that's a really sort of important piece that we really need to consider as we iterate on our overall OGMP implementation. Now, an additional tool that can be really useful as you're sort of going through this process is something that can help you identify what's contributing to your uncertainty, sort of with the idea of pointing you in the direction of the sort of areas where your measurement program might be failing. So what this chart on the bottom is showing is basically the relative contribution to overall uncertainty that I'm seeing in each of my major site types. So basically, how much is each of my emission sources contributing to my overall uncertainty in a given site category? So in this case, I can see that for my site type A, the vast majority of the overall uncertainty associated with my site type A values, at least at the level 4, is coming from my pneumatic valve measurement program. So what you can use this to do is, as you begin to evaluate options for reducing discrepancies or reducing your overall uncertainty, where is a good place to start, and how can you actually investigate the information that's actually associated with that? In addition to this, one final thing that we also like to include is basically a summary of sort of extraneous information that you can sort of use to aid your investigation. So what we're surfacing here is actually a collection of non-routine emissions events that a user might be collecting in the product. And this is something that a lot of our clients are doing today. But basically, like, as you record blowdowns or as you record workovers, the details of that specific occurrence can be captured and cataloged and then ultimately surfaced here in this table to aid you in your investigation. So if I was sort of doing this reconciliation analysis and I identified that there was a significant difference between my level 3 results or my level 4 results and my level 5 results, is it possible that there's stuff that's been happening at these sites that might contribute to a difference in the emissions that my measurement technologies are actually capturing? So ultimately, what this whole tab is aimed at doing is bringing the data that we've sort of collected throughout our OGMP process into a single view to make it easier for us to improve the process for next year. By its very nature, OGMP is a very iterative thing. So basically, as you kind of go through this process, you need to evaluate where there were deficiencies in the previous iteration and how you can improve on those deficiencies for the next one. And that's very much what we're sort of attempting to support users with doing in this tab. So at this point, what we've kind of gone through is we've established that asset inventory, we've run our level 3 calculations, incorporated our level 4 calculations, and then using site levels, we built out our level 5 emissions inventory, and then ultimately all of that information has been brought into this final dashboard to aid us in sort of what we call the reconciliation, or what OGMP would call the reconciliation. And a lot of this data is ultimately what's going to be fed into your annual OGMP report. So basically, this information can then be pulled out either in, depending on the specific format that you guys are interested in accessing it. All of this information lives within the product, so it becomes reasonably easy to access it, modify it, and ultimately prepare it for actual dissemination, depending on who you're actually presenting that data to. So I'm going to pause there. I think we've kind of walked through the overall process and what that can kind of look like in the Validere platform. So I'm gonna give everyone a chance to kind of pause, and if you have questions that you've put into the chat, or if you have any sort of specific questions, we'll try and pick those up now. I'm gonna stop sharing just for a second, and let's take a look at what's in the Q&A here. So one of the first questions we have here. So we have a question from Allison. Can you speak to if/how a detailed measurement-based methane emissions inventory could potentially be used to predict future emission source performance or upset events? Curious if there may be a potential to harness all the data being acquired in a more powerful way, for example, for preventative, preemptive maintenance. So the answer is yes, absolutely. So we haven't really incorporated that element of, I guess, sort of, predictive analytics into this specific demo. I'm actually going to reshare my screen just in case I need to show something. Actually, I don't know if I can. But yes, Allison, I guess to answer your question 100%. So for a lot of our clients, we are starting to capture information about these methane events. And the idea is that as you sort of build out that repository of data, the analytics that you can perform, in this case, specifically some of the predictive analytics that you can perform really starts to expand. So that's something that we're definitely looking at. For a lot of clients, we also do things like leak inspection and repair management. So that data can also be incorporated to sort of, guide those predictions and sort of tune those forecasts. Question from Alice, are we going to share yes, I think someone's already answered that. Yes, we definitely will be sharing it. And then any questions in the poll or in the chat? Question from Tim, is uncertainty propagated as per IPCC 2000, i.e. square root sum of squares? Yes, that is how the uncertainties in this dashboard, and basically all of these dashboards, have been propagated. So essentially both the measurement uncertainty, the cumulative uncertainty from both the statistical and the measurement, all of that is being carried forward. Great. I don't know if we have any additional questions. If you have other questions and you haven't asked them here, we'll be following up some emails after the webinar, so you can reach out. We'll be happy to answer additional questions after the session. But I think unless we have anything else, perhaps I'll pause it there.
I think we're getting a couple more questions. Let's just share this one, Cyrus. We got one from Nadeem. How are you connecting to the SCADA data?
Great question. So we can connect to SCADA data in a number of ways. So Validere supports essentially what we call the data platform. And through the data platform, we can pull data from SCADA systems via sort of any sort of mechanism of push or pull. So we have a direct API. We can pull data into the platform directly through that. There's sort of a few different ways that it can be approached, and really it depends on sort of how that source data system is set up and what's easiest for the client.
Awesome. And one more from Tim, is the uncertainty at the source level assume normal distribution?
So for these specific uncertainty calculations, we were actually assuming a log normal distribution. We validated that. That's not an aspect of this that we really got into, but during an actual OGMP implementation, the calculations that we're encoding to actually perform those uncertainty calculations would all be accounting for the shape of those distributions. Great. Fantastic. Well, I think unless we have any other questions, we'll probably call the session there. Thanks so much for joining and appreciate all of the questions. We'll be following up with some material after this. So if you do wind up having additional questions, certainly feel free to reach out and we can follow up with additional details after the fact. All right. Fantastic. Thanks so much, everyone. Take care.
Thanks, everyone.